Hello everyone. Am I audible to you all? Is the screen visible to you all? And I'm audible to you? Everyone. Good afternoon. Good afternoon, everyone. Good afternoon, Jyoti. Good afternoon, Vaishnavi. Everyone, good afternoon. How are you guys? कैसे हो आप सब? Just wait for 1 or 2 minutes more. Let the others to be joined. Then we will start. Okay. Okay. So good afternoon, guys. How are you all? I hope you are doing good. So I welcome you all in this session of moving charge and magnetism. This is our lecture 3. In the previous lecture, we have talked about the Biot-Savart law, which is specially to find out the magnetic field around a moving charge, which is carried out by a conducting wire. Okay. So we have derived the expression. We have seen each and every term of the expression, how the expression is to be derived, what are the assumption, what are the conditions, and what is the final results. So we have talked about that. Finally, is magnetic field is a vector quantity, so we have to find out the direction also. So direction wise also we have seen this. We have already find out the direction, how to find out the direction of magnetic field by a current carrying conductor. And yes, of course, we have also talked about uh, the similarities and differences of Biot-Savart law with the Coulomb's law, because both law is related to the field which is created by the one of the properties of matter. So that particular field is created by, in Coulomb's law, is by the charge. Magnetic field is created by the moving charge. Okay. So by changing of electric field, we are creating this magnetic field. So both the fields are interrelated. That is why the two laws has some similarities and the differences in between them. And we have already talked about that. What are the similarities? What are the differences in Biot-Savart law and the Coulomb's law? I hope You have remembered that. What are the similarities? What are the differences? Can anyone state one of the similarities, one of the differences? If anyone remember, Vaishnavi, Jyoti, Sakshi, and any others, what are the difference, one difference and one similarities in Coulomb's law and Biot-Savart law? Anyone wants to? In Jyoti, Sanjana, Vaishnavi, any one of you? Tushar, Chandana. Okay. So the basic difference you can say that the this Coulomb's law is derived from a scalar quantity. The electric field is coming out of the scalar quantity, which is charge, but the magnetic field is not coming out from a vector quantity. It is coming out from a it is coming out from a vector quantity, not the scalar. The current element that we choose, ठीक है ना? Ideal vector. That particular thing is the vector quantity. ठीक है? Clear? Yeah, very good, Sakshi. Superposition principle applicable for both. This is the similarities and the difference I have told. Okay. The magnetic field is coming out of a vector quantity which is ideal vector. This is the current element. Current element. And the electric field is coming out of charge. And charge is a scalar quantity. Okay. Now, so let's just continue with this and we will draw this. Magnetic field due to a thin straight current carrying conductor. So the same expression we have did for, if you would remember, the same expression we have did for electric field due to a current carrying wire, due to a charge or infinitely long charge wire, है ना? Very good, Jyoti. Long range may as is depicted inversely on the distance square. Good, very good, very good. So this expression for electric field we have also derived in the previous lecture for the infinitely long conducting wire. Okay. The same thing that we are going to do here is to derive it for the magnetic field. Okay. So magnetic field due to a thin straight current carrying conductor. अब देखो इसमें आपको क्या क्या नोट करने वाली चीजें हैं ताकि आप खुद भी इसे डिराइव कर पाओ. फर्स्ट ऑफ ऑल, ये जो व्हाइट कलर का आपको लाइन दिख रही है, दिस इज द योर करंट कैरिंग वायर. ठीक है. इस पर्टिकुलर करंट कैरिंग वायर को हमने कंसिडर किया है और इस करंट कैरिंग वायर का हम नाम लिखते हैं एबी. ठीक है. वेरी गुड, साक्षी. एंगल डिपेंडेंसी ऑन बीएस एंड कूलम्स लॉ डज नॉट एग्जिस्ट. वेरी गुड. सो मैग्नेटिक फील्ड में बायोट सेवर्ट लॉ में that particular magnetic field depends on the angle. But if you talk about the Coulomb's law, it does not depend on the angle. Okay? It's pretty clear. Very good, Sakshi. That's why I say that you are paying attention to the lecture and it's good for you, for the future, for the examination and all. Okay, keep it up. So this AB is a current carrying conducting wire. This is a thin straight current conducting wire. Straight wire. Now this is particular point B, P, where we have to find out what is the value of magnetic field at this particular point. Okay, and the direction of current is up, and let's say the current that is flown in this wire is I. Okay, so what we are going to do in the Biot-Savart law, if you have paid attention to that, in the Biot-Savart law, we have considered a wire infinitely current carrying wire, or you can say the moving charge carrying wire. Okay, we have always considered a very small section of it, and we will position the point where we have to find out the magnetic from this current element via this R vector. Okay, this is point P where we have to find out the magnetic field. Now this is I'm talking about the Biot-Savart. The same thing we are going to apply here. So I current is being flown in this wire. This is DL. Okay. So current element here would be IDL vector. And we know that IDL cross R vector divided by R cube mu naught upon 4 pi. This is the dB magnetic field at this point, which is finally coming out to be mu naught upon 4 pi IDL sine theta divided by R square. Okay. The same thing that we can do here. Yes, definitely we can do. Now let's see how we can do it. So this wire is AB. This point is P, where we have to find out the magnetic field. And the wire in current in the wire is I. So what we have did, we have taken focus on this yellow dotted line. We have taken a perpendicular distance from the wire to this point P, where we have to find out the magnetic field. And this distance is named as A. Okay. This distance is named as A. Now what we will do, according to Biot-Savart law, we will join this current element. The length of this current element is DL. We will join this current element to this point P via a position vector R vector. Let me change the color here. So the position vector here we will take is R vector. Okay, no problem in that case. Now, the angle of this current element from this point P, from this baseline, is theta. Okay, the upper limit, because this line can extend up to point A, इसके beyond तो ये नहीं जा सकता. So the upper limit is phi 1 and the lower limit is phi 2. Got it? And these limits are the limits of this point P. The point P can align itself maximum to phi 1 and maximum to phi 2 in the lower direction. Got it? किसी को कोई doubt है? Any kind of doubt till now? Because the terminology is very crucial part to understand. Okay? So if you paid attention that how I'm naming these terms, what are the values of these terms, you would never find any trouble with this expression. So if anyone has any kind of doubt, you can ask right now. Anyone, any kind of doubt? You are open to ask. Okay, any point of time. So now, till now, we have defined the current element, DL. Okay. We have defined the value of current in the wire. Okay, upper and lower limit, what is it? Dekho, this point P can go up to this. So here, if you make this here, if you make this dotted line, what is the angle? So the maximum angle this point P can sustain, because we are not considering the infinite wire. We have considered a finite wire. So this line, this DL vector can go up to point A. इसके beyond तो नहीं जा सकता. And this DL vector can go up to point B. इसके beyond भी नहीं जा सकता. So when it is going to point A, this theta can maximum goes to pi 1. Now you understand? This theta can maximum go to phi 1, and in the lower direction it can go to phi 2. So that is why I have defined as the limiting angle of this. Okay? These angles will going to help us when we are putting the limit in integration. Okay? Now let's just consider this length up to this dl is L, and the current element is very small, which is dl. Okay, got it. Now this angle here, let's say, is alpha. So can anyone tell what about this angle, this particular angle? Can anyone tell if this angle is alpha, what about the value of this angle? Anyone? I want to check your brains. Sakshi, Vaishnavi, Sanjana. Anyone? What is the value of this angle, this particular angle? Very good. Who is this? Yeah, obviously. Sakshi is this. And this is 180 minus alpha. Because this line is making 180 itself. And alpha is the section here. Alpha and this total is 180. So this would be 180 minus alpha. Very good. Now all the decoration has been done. Now move back to the real event. Now here what we will do we will write by Biot Biot-Savart law. Due to this current element at this point P, what will be the direction of field? I have already told you in the previous lecture that put your thumb in the direction of current and curls your finger. Your finger is going downside, which means at point P, the magnetic field is inside. So at point P, the magnetic field is inside. And due to this current element is very small, so the magnetic field at point B will be very small. This would be given by dB vector is equals to mu naught over 4 pi I dl cross r vector upon r cube. Now r vector ko we can also write r into r cap. R is the magnitude, r cap is the unit vector. That r would definitely cut out one of the power of this r cube. So the finally, if we talk about the magnitude of it, we would have mu naught over 4 pi I dl r sine. Now, who is going to tell me what is the angle? Now, let's just clear off this r also and directly write it here, r square. Now, what about the angle? The dl vector is like this, upside. The head of the arrow is upside. The tail of the arrow is downside. R vector is like this. Now we have two angles here. If we will focus, this is alpha and this is pi minus alpha. Okay. Then I have, mean though I have told you or not, your teacher have told you or not in your 11th class, in the vector part of the physics. So in vector, we would choose always the angle when the tail of the angle is being joined. अब देखो tail of the angle is being joined for pi minus alpha. So we cannot take here the angle is to be alpha. The angle here is to be pi minus alpha. Because दो वेक्टर के बीच में एंगल कौन सा लेना है जब उनकी टेल एक साथ जुड़ी हुई है. देखो इनकी टेल आपस में एक साथ जुड़ी हुई है तो इनके बीच का एंगल ये वाला एंगल आपको लेना होगा, नॉट दिस. ठीक है. आई होप यू वुड अंडरस्टैंड दिस. This is the beauty of physics that we have to make continuously. So here the dB is, I am just writing it dB. You would understand that I'm writing the just the magnitude only. Mu naught over 4 pi I dl sine alpha divided by r. You know that sine pi minus alpha is sine alpha because pi minus alpha is in the second quadrant. I hope you remember some of the stuff of chemistry, sorry, the trigonometry in your 10th and your 11th. Not those who have opted the biology in 11th. They are pretty much sure that they have opted, they have been through in the class 10th the very special topic that is trigonometry. So this is from there. Okay, very good, Sanjana. So sine pi minus alpha is sine alpha. Who is going to tell me what is the value of cos pi minus alpha? Tell me in the chat box rapidly. Okay. Inside. तो इसकी डायरेक्शन के लिए आई हैव राइट इट आउट हियर इनसाइड द प्लेन. ओके. नाउ let's just make it very clear. I'm just taking this that particular section of length L. I hope you have remembered the figure. देखो, this is L, this is A, and this is R. Okay. This is L, this is R, and this is A. And this angle is theta. What we are going to here, we will write tan theta. Tan theta is equals to L upon A. So we can write L in terms of A, which is A tan theta. Why we are doing this? There is a story behind it. If you will focus on the expression of dV and it just integrate it, so you have to, because alpha is also variable. If theta is variable, then alpha will also vary. Okay. And here the dl is also variable. So two types of variable we have here. So what we are going to do, we will superimpose these two variables into only one variable, and that should be theta. Now, how we will do that? Focus on this part. So L को we have write in terms of A and tan theta. A is constant. Okay. Whether you take point P here, here, or here, the value of A will be constant because it is the perpendicular distance which is not going to change. Now, if you differentiate this, it will become dl is equals to A. Now, what is the differentiation of tan theta? If anyone remember, tan theta का differentiation is sec square theta d theta. This is how we are going to do. Now, if anyone is having problem with this expression, now how I have derived it, so do not worry about it. Just differentiate this L with respect to theta as you do it with respect to x and y. So dl by d theta will be A is constant, which is taken out. Tan theta should be sec square. Okay. Now dl को you can write A sec square theta d theta. Sorry for the trouble. Now, no one has answered what is the value of cos pi minus alpha. Okay, guys. So dl here is A sec square theta. Now, what you can do, you can replace the value of dl in terms of theta. Got it? Here's the expression. Firstly, I will write it here. The dB here is mu naught. This is equation 1, you can say. Mu naught over 4 pi I dl sine alpha r square. Okay, got it? Now, what is exactly alpha? Alpha is this angle. So can we write alpha is equals to 90 minus theta? Can we write that? This is theta, this is alpha. We can write alpha is equals to 90 minus theta. Anybody, any problem? Any problem with that? I hope so. I hope not so. Sakshi, Jyoti, Sanjana. Am I not audible to you? All of you? Is there any problem with the communication? Sakshi, Chandana. Anyone, please respond in the chat box so that I would know. Okay, so answer my questions now. What is the value of cos pi minus alpha? Now put the value of dl here. Mu naught over 4 pi I dl की वैल्यू इज a sec स्क्वायर थीटा d थीटा sin अल्फा को we can write sin 90 minus theta which is cos theta. Sin 90 minus theta is cos theta divided by r square. Now what we can do? We can take the dB is equals to mu naught over 4 pi I a. This you can write as cos theta को you can write 1 upon sec theta. This will become sec theta d theta divided by r square. ठीक है, got it? Now one of the thing that we have also, that is r. So r को भी हमें क्या करना पड़ेगा? रिप्लेस करना पड़ेगा. देख, r को we can write what in terms of sec theta? We can write, yes, if you write sec theta in this triangle, it would be, it is the inverse of cos theta. So if you write cos theta would be based upon hypotenuse. So you can write r is equals to a sec theta. Okay, got it? So dB here would be mu naught upon 4 pi I a sec theta d theta divided by r square will be a square sec square theta. A and a will cancel out. Sec theta say one of the power will cancel out. And 1 upon sec theta is nothing but cos theta. So you can write it as mu naught over 4 pi I cos theta d theta over a. Okay. Now you can say that dB is equals to mu naught upon mu naught I upon 4 pi a cos theta d theta. ठीक है. Now you integrate this term. Now what is the value of theta? What is the limiting value of theta? Theta can go up to phi 1 and go up to phi 2 in the lower side. So lower side may you have to move according to anti-clockwise, and to measure this angle you have to move up in the clockwise sense. So clockwise sense we will take positive, anti-clockwise sense we will take negative. So you can say that minus phi 2 to phi 1. The same thing that we have did in the, that when we are deriving the electric field due to infinitely long charge wire. Okay. So here we will get the B is mu naught I upon 4 pi a. Cos theta would be the integration of cos theta is the differentiation of sin theta is cos theta. ठीक है. Differentiation of cos theta is minus sin theta. So integration of cos theta is in inverse of that. So integration of cos theta is sin theta. Here the negative sign will not come. Sin theta. Okay. Minus 5 by 2. 5 to 2. Now B here is mu naught I over 4 pi A sin phi 1. And sign you can say ki it vomit out the minus sign. So minus phi 2 will become minus sin phi 2 and the minus minus will become plus. Got it? So this is the final expression that you will have in your head. Okay. Now any kind of doubt guys? Any kind of doubt in this expression? Anyone? Sakshi, Sanjana, Jyoti, Chandana, any kind of doubt? Okay, Sakshi got it. Jyoti, you are having any trouble with this expression? Okay. Now we will discuss some case first. Okay. The first case is that when phi 1 is equals to phi, which means the point P lies at the perpendicular bisector of that particular line charge or the current Y. So in that case, B would be mu naught I over 4 pi A 2 sine, and this would be equals to phi, let's say. So it will become 2 sine phi. So what we can do? We can just cancel out this 2 with this 4. It will become 2 pi A sine phi. Okay. And these are very helpful formula in the case of competitive examination. Okay. Second case would be due to the infinite wire. Due to infinite wire. Ab dekho, we have discussed a case which is a finite wire. But what if the wire become infinite? Going to infinity. So this is, let's say, the point P. We have not pretty much sure about the end point. They are at infinity. So if the angle is being raised and raised and raised, so we can say the final angle would be here, the 90 degree. Okay, in both the case. So in this case, the phi 1 and phi 2 would become 90 degree. Because at infinity, that particular R vector, which is joining the current element to the point P, will become parallel to the line. And when it become parallel, the angle will become here 90. Okay. This is the important case, by the way. Now, this point B you can write as here the point, here the magnetic field will be mu naught I over 4 pi A sin 90 plus sin 90 will be 2 because sin 90 is 1, so it will become 2, so it will become 2 pi. Got it? Clear? Any kind of doubt? Now the third case is semi-infinite wire. Now in case of semi-infinite wire, let's say the lower end is fixed and this is point P here. And this end is going to the infinity. So what about the angle phi 2? Phi 2 we measure to the lower end and lower end is just matching the line with P. So angle here would become phi 2 will become 0 and phi 1, the angle of the topmost end will become 90 degree as in case of infinite wire. So here the expression that you have is mu naught I over 4 pi A. Because one of the sine phi 2, sine phi 0 will become 0 and sine 90 will become 1. So you can say that This is just the half in case of infinite. Okay, this you can remember. Got it? Case fourth, you can say, if a point lies on the wire, वायर पे ही आ गया आप, देन व्हाट विल हैपन? जब ये पॉइंट भी वायर पे आ जाएगा तो मैग्नेटिक फील्ड की वैल्यू हो जाएगी 0. देयर विल बी नो मैग्नेटिक. नाउ नाउ द कंपटीशन stuff is here. Case fifth. Look, when the point P is not aligned, अब तक जो हम पॉइंट P को क्या ले रहे थे, विद इन द रेंज ऑफ द लाइन चार्ज. ठीक है, विद इन द लेन ऑफ रेंज ऑफ this current carrying wire. But now this time point P is not in the range of this current carrying wire. Now how to find out the the magnetic field at that point? The formula that we are using is same. So what we will do? We will connect two lines with this point. Okay. And we will extend this line charge imaginary to the point P, and then we connect the further ends. Now we have two angles here. First is, let's say, theta 1, and second is, say, theta 2. Now the only difference that you have to make here, that B here would be mu naught I upon 4 pi A. Sin theta 1 is okay because theta 1 we are measuring in anti-clockwise sense. But theta 2 के लिए we are going down, we are moving down. ठीक है, clear? So that is why this theta 2 will be getting negative. So here the field will be sin minus theta 2 in this case only. Okay, clear? Any kind of doubt? Any kind of doubt, guys? Okay. So this is the case that we have discussed. Now, magnetic field on the axis of a circular loop. The same thing that we have did in the electrical portion of the physics. We have taken the ring, annular ring, and we have calculated what is the value of electric field at the axis of the ring. The same thing that we are going to find out for magnetic. What is the magnetic field on the axis of a circular loop? So here we have our circular loop. This is our point P where we have to find out the magnetic field. This is the ring or the loop, you can say current loop. Okay, and these three are the axes. Do not confuse with that. This is x-axis, this is y-axis, this is z-axis. The radius of the loop is r, and we have considered a very small current carrying section or current element ideal in this direction. And we would connect this point P, the same we have did for the line charge. तो ideal को हमने इस point P से connect कर दिया due to this position vector, and this is r. ठीक है, clear है? This length is from the center to that point is x here. Okay, and this particular length is capital R, which is the radius of the this ring, and this r is the position vector from ideal to point. Okay. Now, if you see what will be the field, so according to the direction view, you can say that this is ideal. ये आपका dl वेक्टर है. लेट मी सी, अगर मैं इसे इस तरह से दिखाऊं, ऐसे दिखा दूं तुमको, ये आपका आइडियल वेक्टर है और ये आपका आर वेक्टर है, इस तरफ बाहर की तरफ, बाहर की तरफ। ठीक है, तो अकॉर्डिंग टू बायोट सेवर्ट लॉ व्हाट इज द डायरेक्शन ऑफ डीबी? डीबी विल बी डीएल क्रॉस आर। तो आप डीएल क्रॉस आर करोगे तो इट इज गोइंग अप, गोइंग अप, बट इट वुड बी परपेंडिकुलर टू आर एंड डीएल। और आर यहाँ पे क्या है, इट इज अ लिटिल बिट टिल्ट। देखो, आर इज नॉट पैरेलल, so this db vector should be perpendicular to this r vector and dl vector. ठीक है, now you can see that this db is perpendicular to dl vector also and r vector. क्लियर है? डायरेक्शन में किसी को कोई कंफ्यूजन है? एनी काइंड ऑफ कंफ्यूजन इन द डायरेक्शन? बताओ। नाउ if this angle is theta, this angle would be theta. ठीक है, so we have resolved this db in two component, db cos theta and db sin theta. ठीक है, नाउ इफ यू टेक दिस वन कंपोनेंट डीएल, घूमते घूमते हम नीचे की तरफ आ गए और यहाँ पे हमने डीएल करंट एलिमेंट कंसिडर कर लिया, तो डीएल क्रॉस आर वुड बी इन दिस डायरेक्शन परपेंडिकुलर टू आर वेक्टर। सो इसका ये कंपोनेंट तो सेम होगा, ठीक है, बट दिस कंपोनेंट वुड बी अपोजिट एंड दिस कंपोनेंट is db cos theta. So all the component in vertical direction will be cancelled out. ठीक है, so the only remaining component that we have in the direction of the x-axis, the db sin theta in the horizontal direction. ठीक है, now see here, db vector is equals to mu naught upon 4 pi I dl cross r upon r cube. This is the Biot-Savart. Magnitude wise it would be mu naught upon 4 pi I dl sin theta upon r square. सिंपल सी चीज है। ठीक है, नाउ आर स्क्वायर को क्या लिख सकते हैं? आर स्क्वायर वी कैन राइट एज अकॉर्डिंग टू पाइथागोरस थ्योरम, r square is the hypotenuse, so it will be written as capital R square plus x square. The same thing we have written here. Now the db vector would become mu naught upon 4 pi ideal sin theta over x square plus r square. ठीक है, simply we are replacing the terms, nothing else we are doing. ठीक है, now अब db के दो कंपोनेंट थे, db sin theta, db cos theta, we have talked about in the previous slide. Now the dby will cancel out because if you consider here this one current element, इससे जो फील्ड होगी वो इस तरफ होगी, उसके भी दो कंपोनेंट आएंगे db cos theta, db sin theta. So this component would be cancelled by this component and this would happen for all the same thing. ठीक है, so the vertical component would vanish out, only the horizontal component will be summed up. ठीक है, the next contribution is sigma e dbx will be sigma db cos of theta summation, or you can also replace this with integration. Now cos theta is what? R over x square plus r square raised to the power half. Cos theta क्या होगा? Base upon hypotenuse and r we have as what? Square root of r square plus x square. Same thing is written. Now putting the value and integrating it, देखो यहां से आपके पास फाइनल एक्सप्रेशन जो आया था, इट वुड बी म्यू नॉट अपॉन 4 पाई आइडियल साइन थीटा ओवर एक्स स्क्वायर प्लस आर स्क्वायर. ठीक है, नाउ this is the final way, this is the final expression for all the values. Now you put the value of sin theta. Sin theta is what? Perpendicular r over hypotenuse, which is r square plus x square raised to the power half. When you put this value here, so this r square plus x square power raised to 1, and here we have x square plus r square raised to the power 1 by 2, and ऊपर में we have r. So this would what? Power 1 and half will add up and it will give you 3 by 2 power. ठीक है, same thing we have done here. And this is not cos theta, this is sin theta actually. ठीक है, now by putting the value we will getting this r over x square plus r square raised to the power 3 by 2. Now we just integrate it. So the integration के लिए we only have this term, this dl, and dl is nothing but the length of this circular loop, and length is the circumference of this circle, which is coming out as, look, which is coming out as integration of dl is 2 pi r, which is the circumference of this circle. So bx I cap would be mu naught I r square over 2 times of x square plus r square raised to the power 3 by 2. This is the final expression that we. Now you may wonder that what is the expression at the center of the loop. So put x is equals to 0. This would be the value of the magnetic field at the center of the loop. क्लियर है? यहाँ तक किसी को कोई डाउट है? Any kind of doubt, guys? Now, one thing that I wish to tell you. Okay. You can solve this question. I tightly wound 100 tons coil of radius 10 centimeter carrying a current of 1 ampere. What is the magnitude of magnetic field at the center of coil? So center of coil pe we have already talked about mu naught I upon 2r. Since it is having a number of tons, so you would multiply by n. N is the number of tons here. By putting the value, you will get the values. Now this one, this is going to be really very important for you guys. Okay, so please pay attention to this concept. Find the magnetic field at the center of a current carrying conductor bent in the form of arc subtending an angle theta at its center. The radius of the arc is capital R. So here we have this arc. This is subtending an angle theta at the center. Okay. And radius of this is capital R. Okay. Clear? So again, the same strategy we are going to use. And the strategy is very simple. Just take a current element. Take a current element. This is the current element that we have chosen, dl vector. Okay. And this is the direction of current in this. This is the direction of dl vector itself. Okay. So what we are going to use? We are going to apply the Biot-Savart law. According to Biot-Savart law, due to this dl element, the field would be mu naught upon 4 pi I dl sine. I'm not writing the angle. I have to tell you. Okay. Upon capital R. Now, if you will see the dl vector के साथ जो position vector लेते थे हम इस point का लेते थे where we have to find out the magnetic. This point is connected by this line. ठीक है. Although I have shown you a very big picture of dl, dl is very small. So this line could be the radius itself. And you know that in an arc, the radius makes 90-degree angle with the arc. In a circular portion, in a circle, the radius is always perpendicular to any of the point here on the circle. You know that, na? Okay. So that is why this angle would become 90 degree. Okay. So we have dB is equals to mu naught upon 4 pi I dl r square. ठीक है. नाउ अब यहाँ पे फिर से dl को रिप्लेस करेंगे. देखो ये एंगल जो सबस्टेंड किया है ना dl ने, dl बहुत छोटा है तो एंगल भी बहुत छोटा सबस्टेंड किया होगा, विच इज d थीटा. ठीक है. क्लियर है? Got it? Now we can replace this dl with the formula that angle is equals to arc upon radius. So angle is d theta. Arc is what? dl, length of the arc, and radius is r. So we can say that dB is equals to mu naught upon 4 pi I dl. dl को रिप्लेस करना है. dl is r d theta divided by. Okay, we are taking the limit as theta na. So we have to take this angle as completely, this angle is pi and this angle is theta from where the current element has started. So r square, this will cancel out. dB is equals to mu naught upon 4 pi I d theta over r. Now mu naught I and 4 pi r is what? Constant. So we can take it out and integrate this a whole expression. So mu naught I upon 4 pi r. This theta, integration of d theta. Now integration of d theta is what? Pi, because theta can extend up to pi. This would be pi. So here the b vector which you have is mu naught I upon 4 pi r into pi. So this is a very important expression that you will keep with yourself. Okay, got it? Now यहाँ पे आपको ध्यान क्या रखना है? This phi you have to put always in radian. So phi की value always in radian you have to put, not in degree. ठीक है? Clear है? Okay. So this is it for today, guys. Any kind of doubt if you have, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsible. Take care of yourself. Take care of your study.